All right, so I guess we're here, and this engine block just so happens to be out of this beautiful, beautiful Toyota Tacoma. And yeah, it's costing me a lot of money, so I guess it's time to rebuild. Well, I'm not doing a full rebuild on this truck, but I am, I did have the machinist out in Belgrade take 6 thou off the block deck and 4 thou off each of the heads. Not sure if no, I haven't showed you all yet. Oh, let's see, rotate this up, front of the motor, so this would be the driver's side. See, yeah, right under here, the head gasket was blown right there, and it was blown into number 6 cylinder. See how close the coolant passage is right there? So I pulled the pistons out of it. Now I did a couple preliminary checks, which you can find in one of my other videos about testing for a blown head gasket in this truck. All these had 165 to 180 PSI-ish. I suspicion that'll go up with the new head gasket, clean parts, etc. One of the considerations that I had too with those good compression numbers and good oil was whether or not to hone these cylinders out. But since I'm not taking these oil jets out, A, and B, more importantly, since I'm not replacing the piston rings, I'm not going to clean these. I'm not going to hone these cylinders out with a fixed stone hone. I'll leave that up to the machinists. So these are the journal type bearings. Now, as you'll notice, I've put a couple of them in after getting the block, and there's the box of clean parts. I still have yet to clean the pistons. But all these front 2 bearings are in the block here. And you'll notice that I can still catch my fingernail on the edge of each of these bearings, which means that the amount of crush that's still in them that was there from the factory is good, right? Even though these are old bearings, I'm still going to reuse them because they look beautiful. They look just gorgeous. These are Toyota bearings, and they have the witness mark on the side where the tang would go, and that lines up right here. So long as you keep your bearings in order, you can tell which direction they go. I'm using shop towels to clean them off. Always use a lint-free shop towel, which I'm not doing, but if I blow my motor up, I'm just going to shoot myself. Anyhow, I also noticed these little nick marks from where the machinist put it on the rack in the machining, or in the wash cabinet. You want to take a razor blade. I got a little Napa special razor blade like this that I use to just ever so gently deburr that surface right there, just to make sure the bearing sits flat and doesn't get warped, doesn't have any high spots on the back of it. I'm going to go ahead and plop the bearing shells in, and I'm also going to use some either wheel bearing grease, or I like the Tranny Doctor's assembly glue. Let me see if I can find it. This stuff, it's really thick and it's really tacky, and it's used for building transmissions. But as you can tell, this stuff's hard. It's almost like beeswax. A little softer than beeswax, but it's very sticky stuff. It's good for rebuilding automatic transmissions. Comes in green for manuals and, manual transmissions, I think, and then engines, you can use this, and then red for automatic, so it doesn't alter the color of the automatic transmission fluid as it melts. I'm also going to be using some of this lubriplate on these bottom end bearings, because I don't anticipate I'm going to have this motor back probably for the next month, because I have to attend school, and multivariable calculus and sedimentary petrology are hell. So anyhow, we'll get this done as we can. I just want my truck back. I really, really want my truck back. It's been a month and a half. I bought this truck so I wouldn't have to work on it. And look at him. He's just gorgeous, but you know, you can't always have what you want, so patience is key in a process like this. Another note, since these are a parent bore engine, and another thing I don't like about modern engines is how they're open deck. See that? See that shit? Open deck, and there's only 4 bolts per cylinder versus, oh, you didn't see that, but there's only 4 head bolts per cylinder, 1, 2, 3, 4. Whereas on the old IDI sitting over here, which I also did a video about because I have all this knowledge in my brain that I just have to share with other people who don't give a shit. There's 1, 2, 3, 4, 5 head bolts, and it's a closed deck. So these will blow head gaskets, but that's because people are retarded and have to put turbos on them when, you know, it's a 40-year-old diesel. And if you want to wreck it, you can, but... Oh, this one's been sleeved too. Now that leads me back to what I was saying, is if you blow a head gasket in this and it's lost compression on a cylinder, have it bored over 10 thou and get some oversized pistons, or have it sleeved and then get original equipment Toyota pistons over there, short skirt gasoline engine pistons, whatever. But Toyota parts, they do last forever. Unfortunately, though, these open deck design blocks tend to blow head gaskets, so don't overheat them. Don't overheat them and do your coolant maintenance. You should be fine. Well, I'll make another segment here in a minute. I got to clean up the end of this crankshaft. Oh, here, I can show you that too, in the plastic even. You can see that groove? That groove there is the reason that manufacturers such as Napa, SKF, make speedy sleeves or make crank repair sleeves, and they're generally 1/1000th to 1/1000 thick of high quality, I think it's spring steel. And then you hammer them over the end of the crankshaft, or the stub nose, the harmonic balancer, or whatever it is that you happen to be needing to, repair, and that provides a new sealing surface. And generally you can get away with using the original type seal just in the front bore there. This one's neat too, because the cams, or the crank sprocket, also has its own oiler, so nifty. You know, you hear shit about men like Leonard Euler or Joseph Fourier, and it's just amazing. These people had multivariable calculus figured by like 1700. And they didn't have a calculator. They didn't have computers to model this. It was just a lot of thinking and a lot of, well, I can't say that because that's offensive, but, you know, smart people. Smart people. Oh, another word of warning from the wise. Once you get your machined heads back, store them with rags over it so that way you don't drop it. I like to store it on top of the workbench or something so I don't, you know, risk kicking it. I had them on the floor over there just when I brought them home, but I like to store them up top here so that way I don't risk damaging this freshly machined mating surface. Another thing is make sure that your machinist knows what they're doing and knows what surface roughness average to put on these cylinder heads, because the multi-layer steel head gaskets are a lot more sensitive than the old composite type head gaskets. As you can see over here, again off the old IDI head, these things don't give a flying fuck what surface roughness. You can put 60 grit sandpaper on there and they'll seal for a while. I mean, it's an old IDI, so it'll run without a head gasket, or it'll run with a blown head gasket just fine. But that is to say that surface roughness average is very important, especially on multi-layer steel head gaskets, but even on composite gaskets, it's important. I'm just bullshitting you. But anyhow, all right, that's enough rambling. Now, hopefully I remember to mention this again, but whenever you're putting your, so that's the oil pump housing, whenever you put that back together, make sure to use engine oil or gear lubricant. Don't use something thick like this assembly goo. I've had bad luck with that in the past. You know, use a thick oil in it. Mixture of gear lube and transmission fluid, I've heard, is what works best, but you do you. But you'll want to lube these up with something decent, good quality synthetic engine oil for a newer engine like this, or a something good like that. The lubriplate stuff works pretty good. Next things next, once I get these lubed up, I'm going to go ahead and wipe these out with a clean rag. This stuff needs to be surgically clean. I mean, you can see my hands are fucking filthy, but that's because I'm a greaser. Anyhow, make sure that the parts, though, are surgically clean. I don't care about me, but my baby needs, you know, surgically clean stuff. And yours will, too. Otherwise, you will risk cutting nice grooves from chunks of siliciclastic and carbonate sediment and other grit and grime from the road that accumulate in here, and we'll score the shit out of the bearing. Alright, you can see how I've lubed up the main bearing here. I put some of that green tranny lube on there. It's like a glue, but it's actually a lube, and it'll melt away once the engine heats up. Make sure that these oil grooves face the rotating assembly. Those allow for oil to escape and allow for oil to be displaced through this bearing surface. Also notice the direction that the tangs come out. I don't know if this is right, but it seems right to me. Anyhow, make sure too that these surfaces are lubricated once you've put them in, and try to line them up so that way they're mostly flush with the top. And then you'll notice that these tangs will interlock with the tangs on this guy. There's that one, and there's that one there. Another thing that I've found that works quite well for cleaning engine parts is kerosene. This is 1K heater fuel kerosene that's been used for, God, cleaning bearings, I've cleaned heads with this, all sorts of stuff off of multiple different engines. But the one thing that you're going to want to do is, well, I'm not going to clean the bottom or the big ends of the rods, because you'll notice I have the bottoms of these marked, and it looks as though I marked them in a retarded way. I think I marked number 3 as number 5. That's funny. But go ahead and use a paint marker and mark your rods like that. Yeah, that's supposed to be 2, 4, 6. Lol. Anyhow, as you can tell, I'm not the smartest. Not the brightest light bulb in the knife block, so anyhow, I'm gonna let these soak overnight. What I did is I made sure too that all these piston rings are free inside of their ring lands, because if any of the rings are seized, then it's absolutely pointless. But go ahead and soak them in kerosene, then clean them with a nylon brush, nothing more aggressive. I cleaned out these bores where underneath of where these journal bearings sit with a brass bristle brush. And similarly, I clean these mating surfaces because there'll be silicone in here and that warp can be taken up. But on these pistons, it's absolutely imperative that you use something softer than any of the metals that are present. All right, so I have these in here: 1, 3, 5, 2, 4, 6. So that's 6, 3, 5, 1, 2, 4, in case I forget. Aluminum is very rarely found alone in nature. Whereas the guests of Napoleon ate off of gold spoons, Napoleon allegedly ate off of an aluminum spoon. It was prized going back to antiquity by ancient Egyptians, etc., being found only in meteorites, where it was cooked, melted, and then solidified above our atmosphere. Aluminum oxide, otherwise known as corundum, has an 8 hardness on the Mohs hardness scale. It is one of the hardest naturally occurring minerals that we know of. Brillo pads and abrasive pads happen to use aluminum oxide, which is why they're such a good abrasive. And a combination of the fibrosity of a Brillo pad as well as the extremely hard nature and the kind of fracture that I believe corundum is a monoclinic crystal system. It is euhedral, and it forms what's the hexagonal crystals. It's a tall sphere with 6 sides to it generally. Now those sharp crystals will get into engine blocks, and it's especially bad on aluminum blocks, but it can also be very bad for cast iron blocks. And it'll get into the small pore spaces of these aluminum blocks, even after you've washed it. And by the way, when you put it through a wash cabinet, that accumulates in the bottom there. And Toyota Motor Corporation, as I understand it, has done quite a bit of research into rebuilt engine failures and has found that those Brillo pads and the aluminum oxide associated with them is one of the leading causes of the destruction of engines because it's so hard. This steel is only maybe a 4 or a 4.5. The steel backing here is only maybe a 4.5 on the Mohs hardness scale. And this aluminum Babbitt material, I can just about scratch with my fingernail. It might be pewter, I don't know, which is a good thing that I don't know because it means that the bearing material isn't worn through. There's a couple of different constructions of bearing you can have. Well, they're generally steel backed, and today's bearings are steel backed. But they can have 2 layers, a layer of copper and a layer of aluminum, or they can have a layer of copper, then pewter, then Babbitt, I think is how it goes, or maybe it's copper, then aluminum, then Babbitt. There's a couple different kinds, but if you see multiple different colors, it means that the bearing's worn through, much like it was on that engine. I can post a picture in here if I remember. That is to say, if your machinist is very anal retentive, don't use a Brillo pad, or they might refuse to clean and work on your engine because they don't want to get the aluminum oxide and Brillo pad fibers into their wash cabinets and risk destroying engines. I had this crankshaft magnafluxed, cleaned, and polished, and as you can see, they polished this fucking oil on my... That's a little better. But as you can see, they polished these bearings back to basically a mirror finish. I don't think that'll have any effect on the bearings, but this brings me to my next point. Oh, I opened it from the wrong end. Oh, you'll have that. Get my personal information. Okay. Turn that upside down. So here's your oil pump drive gear. There's your crankshaft reluctor wheel that sends a pulse. I think this is a 36-2 is what they're called. Crank reluctor for a Hall effect sensor. And then go all the way down here to this end. This is the flange where your flywheel, your flex plate bolts up. And there's a better view of the groove. So instead of sanding that down with a Brillo pad or with emery cloth, both of which use aluminum oxide, we're going to use some very fine body sanding paper, 600 grit black body sanding paper, which doesn't have the same properties, at least as I understand it was recommended to me for internal engine components. I have had bad luck using those Brillo pads as well on things like output shaft seals in the back of a BorgWarner 1356 transfer case in my 92 Ford F-250, whereby I replaced the seal, which was a dust-booted type, lip type seal, and it still leaked after I did that, after I cleaved the front stub shaft of that yoke with emery cloth. So we're going to try this, try to get the groove out as best we can before laying it in there. This is recommended to be used wet, so I'm going to fill up my little mushroom can with some water after I rinse it out, and then we're going to sand in a bid to remove any burrs and smooth out that mating surface to ensure that the new seal will seal against the crankshaft. Now that I've dropped the crankshaft into the engine, I'm going to go ahead and very gingerly push, so let's see what I'm doing, there you go, push these thrust washers back down into their bores. Make sure they're just about seated right there. And then I'm not going to rotate the crank right now because that can risk spinning the bearings out of their bores, and I'd have to shove them back down. So what I'm going to do now is go ahead and grab, there's those two thrust washers in between those four mains, and I'm going to put the thrust washers in with some of that assembly goo after I clean them up. And then we'll go ahead and put the mains in with that assembly goo and tighten them down. If you're this far into the engine build, you should know this, but never, never, never put oil on the back of a journal bearing. You will risk spinning it in its bore, even if it has tangs, and these ones don't have tangs to retain them into the block, which is really weird because there's a slot for tangs right there. I'm wondering if this is a reman motor, but it's got Toyota parts in it, so I don't know. Another thing that you can do, and you probably know about this, but there's this plastic stuff called Plasti-Gauge. And Plasti-Gauge is used to size the main bearings to their to the connecting rod and bearing housing that they're into, the main bearing cap. God, I don't know where I put it. Well, look up Plasti-Gauge. It's the stuff that looks vaguely like a ruler, and it's this thin strip of molded plastic that you place perpendicular to the rotation of the engine, and then you tighten the bearing down over it, pull the bearing cap back off, and you check its width against the width of the oh, here it is. I knew I had it in here. Okay. Yeah, So here is the ruler looking thing. And then this is an inch plastic gauge. Watch as I fuck one of my main bearings, that'd be funny. And then, let me see. Is there any in it? Okay, yeah, you can see there are these small segments of plastic in there. And then you place one of those segments of plastic this way in the engine. Not, of course, over an oil hole, but place one of those in there. Tighten the main bearing cap over it, and then take the main bearing cap and main bearing back out, and then check the width. And however wide it is, after being squished down, you compare to this. And that'll tell you how much clearance, roughly, is in your engine, or is in between your main bearing and your connecting rod. Now, the best way to do it's with a properly calibrated, high-quality micrometer, but again, we aren't all fucking millionaires. So, the moral of the story is that cars are expensive and stupid, but, you know, you gotta have them, it seems. Another thing to note, I was worried that I wouldn't be able to fit this bearing in there, but as you can see, it fits just fine between those two. You'll notice that these are offset, looking from the front of the engine. That's normal, that's how it came apart. Okay, so this guy will go in there like this. I've cleaned it up. Shit, there was something else I was going to mention. Oh, I know what I was going to mention. Okay, so I cleaned these head bolts by dipping them in kerosene in here and then spraying them off with some brake cleaner. They aren't terribly dirty, so I think they just go in dry. I don't think you need to oil them up. And then they get torqued to 45 pounds in this order, and then they get torqued another 90 degrees, and then they get torqued, the side bolts get torqued to 18 pounds. Do note that these are I don't want to say stretch to yield bolts, but you definitely want to check the thickness of the shank here to make sure they're not stretched too far. So I couldn't get this main bearing cap to go into its hole there easily, so I had to take it back out, and we're going to try putting the thrust washer into the main cap here and then putting it in instead of driving the main cap in over the top of the thrust washer. All right, to keep these bearing caps aligned, put them into the main cap, or put the bearing shell into the main cap. Fuck, can't talk. Again, with the tang, mark a line there, the witness mark. I had this bearing pop forward about 1/8 of an inch, so I had to take this cap back out and then push the bearing back in. So put it in the cap and align it up how you want, and then set it in there gently. Make sure that where it slides in is nice and clean. 11 a.m. on a Saturday, back wrenching on my baby. And I don't know if you can witness, last night, underneath of this grease, the gall marks here that I had to file down. You got to be really careful whenever you're putting these main bearing caps in that you don't get them cocked to one side or the other, because they'll gall the piss out of the aluminum. And I galled both sides here, so I had to very, very carefully flat file it back flat. And then I left because I was getting pissed off. But you'll notice the way that I have this main bearing shell in the main bearing cap here. You can see it's aligned right there. And then it's a two-handed task, but go ahead and drop it in and make sure that you got even spacing between this casting and then the top of this casting on both sides. And then I'm going to use just a very light mallet. I'm going to slowly tap on each side, and I noticed that this side just went down maybe 1/8 of an inch, 1/16 of an inch, but the other side didn't. Anyhow, I'm gonna attempt to drive this in here. You can see it drove down a little bit by itself. Just wiggle it back and forth. I put some lube on it as well, just a very little bit. You don't want a lot because you can risk slippage. Or not slippage, but I just say it's not good practice to do that. And then I very gently used my hand to just push that in there. Then I let these sit overnight, and then I was able to pull them out. Yesterday evening, I wasn't able to get these in by hand. I had to tap them in almost all of them in with a mallet, but it seems like the block stresses have kind of warped back into place, so everything came out and went back in a lot easier this morning. The next thing I'm going to do is shine a light down in the hole, make sure that the you can just barely see it there. Make sure that the threads inside of there are aligned with this hole. Then I'm going to go ahead and go get the cleaned off main bearing cap bolts right there on the bench. Lovely. Love that. Okay. I'll go ahead and get the main bearing cap bolts off the bench. Again, they've been cleaned. Pistons have been soaking overnight. I tell you what, a fun thought that I had was this engine bay is awfully open right now, and there's an IDI International diesel sitting right there. Now I know the front suspension couldn't take it, and the rest of the drivetrain components just would not have it. But this would be a fun motor to put in a truck like this. I mean, it makes more torque but less horsepower than this motor does. It's 4-liter, but now this thing can be a lot of fun in there. Pointless, absolutely pointless, but it would be a good time. Now, as you'll notice, I have the main bolts placed in here. Right here where my middle finger is, you'll notice that the bolt neck's down. That's where you want to measure the shank of the bolt with your vernier caliper. Let me see if I can set you down somewhere and show you. Okay, so I bought a Fowler vernier caliper because I like good quality tools. I'm going to go ahead, take it, press the on button. This is on, as you can see right there, it says inches. And use the outside diameter to measure it, and then I'm going to place shank right there. The minimum specification is 393 thousandths. None of these bolts came in under 370 thousandths of an inch, so we know they're good. The standard diameter is 420 thousandths. So you can probably get 2 or 3 uses out of these bolts before you have to replace them, but always check every single bolt on the stretch type like this before you reinstall them, because if you break one off, you're going to have to A, pull it out, and then B, it means that the other bolts in the engine, which have been subjected to the same stresses, are probably on their way out as well. In addition to these 4x4, maybe 16 main bearing cap bolts, there's also these hex threaded cap screws, that's what they're technically called, with the washer. And you'll notice the washer has some rubber inside of it that seals in some oil. I forgot to soak these last night. Oh, lovely. So we're going to go ahead and do that. Kerosene here, and then I'm going to clean them off with brake clean. Go ahead and let those soak then for just a minute here. Maybe get some of the schnoo off of them, and then we'll use some Permatex gasket maker where the rubber is, where that old rubber is, to make sure that they seal against the engine block. Because while the engine block is machined, and so too is the main bearing cap, there's still a chance that oil can get through and pass the threads, and then can come out these holes. So I'm also going to go through and clean off each one of these little mating surfaces, and then I'll go ahead and blow them out with my air nozzle. Alright, so what I did, as you can see, that's the bottom of the engine. So these main bolts, or these cross bolts rather, I put Permatex on either side of the washer that underlays the head of this. And I put a thin film of oil from that oil can out of the threads of these. And then I'm ever so lightly snugging them up against the block. That one was even too tight, because I need to torque these main caps first. And I don't want the torque, or the cross bolt caps rather, to affect that torque spec. But I do need to make sure that the cross bolts will go in before I torque down the mains, because otherwise I risk having to untorque the mains and then realign everything. But the good news is that everything seems to have gone together pretty well. So, fuck, I've been out of a truck for a month and a half. So my goddamn truck back. Anyhow, as you can tell, I can spin this over just very little effort. After lubing everything up, and then I just snug these down. I did it in the kind of spiral outward pattern, even just with my speed handle there. But now I'm going to go through and observe the torquing the torquing procedure rather for these, which I know I did last night in the video, but I'm going to start here, and then 1, 2, 3, 4, 5, 6, 7, 8, and then over 9, 10, 11, 12, 15, 16 to 45, and then another 90 on all those, and then go through and do all these to 18 pounds. And the order that's specified, mine's a 1GR, not the Atkinson Cycle 2G in the new trucks. Not gonna lie, the new Tacomas look pretty dope, but these second-gen pre-facelifts and an extra cab are maybe my favorite of the Tacomas. They are, God, they look good. Anyhow, we'll go ahead and do this first, and then we'll do that. What I'm going to do is I'm going to use my good quality Carlisle torque wrench as well. So I'm going to take this guy, and I'm going to set it to 45 pounds. And then I'm going to use my breaker bar here, or maybe I'll use my 3/8 breaker bar, which is right here, and I'll put the extra chunk of pipe on it. And then I'll mark each of these, and I'll show you. I got a paint marker, gold paint marker, and I'll do a tick mark on each one of these, take a picture, and I'll go through, and I'll turn them 90 degrees clockwise. And that way, once the paint mark is turned, I'll know that the bearing cap has been torqued. Okay, so as you can see here, we're working with the V6 1GR 4-liter. It says tighten the main bearing cap bolts, the 2 steps. So the 2 steps apply to the top, the vertical bolts, these ones. Tighten these first, and then cinch these side bolts up. So another thing that I've heard a lot is people wondering about whether or not extensions change the torque of a torque wrench. So in multivariable calculus, what we do is we split up things in terms of vectors. So in 2 dimensions, R2, you have the y-axis and the x-axis, and you have a line, and it's defined as y minus y naught is equal to m times x minus x naught. So you know the point slope form of a line. But that slope part doesn't really apply in 3 dimensions because there's an infinite number of ways that you can describe a line, right? Come up, down, you know, if that's your coordinate system, you can come up and down or in or this way and this way. But the point is if you have a vector, right? And if everything here is 90 degrees, right? So the socket and extension here that I'm pointing to with my thumb are in line with the z-axis, the up axis. And my torque wrench is in line with the y-axis. And I apply a torque, a rotational motion in this direction, right? Then I am only applying force in the x and y direction. The height of the z-plane does not change. Now, if I apply it down here, I have a z component, right? And given the Pythagorean theorem, you know, a squared b squared is equal to c squared, the hypotenuse, right? So you're going to have a component going in the y direction and a component going in the x direction, but you'll also have a component going in the z direction. So that will change your torque. But so long as you delimit the forces that you're applying to 2 dimensions, then you are going to ensure that the amount of torque that is applied across this extension here is going to be the same as what it is at the end of the ratchet head. That is, of course, assuming that there is no torsional or spring twist in this chunk of steel, which I assume is a chunk of hardened steel, not spring steel. Of course, to twist spring steel, it takes a certain amount of force, a certain amount of leverage, right, which will reduce the actual amount of torque observed down here. But I will refer to Adept Ape's video on testing the amount of torque applied with extensions, and then going through and testing how much torque it takes to turn the head of a bolt as sort of supplemental to this video. It's more scientific than my explanation here. But suffice it to say, if you keep everything in line and you keep everything straight and you just turn in this direction, then it should not be an issue. So now that the main bearing caps have been tightened once, they've all been tightened to 45 foot-pounds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I went ahead and I double-checked them all. I just went through, front, back to front. It doesn't have to be in any order, and made sure they're all torqued to 45 pounds. And now what I'm doing is checking to make sure that I can rotate this crankshaft freely. Mind you, I have oiled all of the mating surfaces here, so there's no up and down play. There's very little thrust play, which is to be expected since I'm reusing the bearings, and I measured the thrust clearances on these at 0.006 of an inch, which is well within the factory spec, and it all seems to turn over wonderfully, so, which is a very nice thing. Now I'm going to go over, grab my paint marker, and then I should probably clean off the tops of all these bearing caps, wipe them down with a rag. Should have done this before I put it all in, but stupid is as stupid does, I guess. Okay, so now that these are somewhat wiped off and just able to accept marks from the paint marker, I'll go ahead and mark them all from the center of the bolt. Right, I'll just show you one from the center of the bolt out like that toward the front of the engine. And I'll be consistent to make sure that I don't have any questions going forward. If you mark all the way across, then you won't be able to tell where you started and where you ended. So it's important to mark just 1/2 like that. And then you'll know where 90 degrees is. I'm not particularly concerned with getting it exactly to 90 degrees. These are all used bolts, and I'm not rebuilding this engine, but if you have an angle meter, definitely use it. I don't, because I'm not, rich, but if I had a spare 10 grand, I would have just bought a Toyota Reman motor, so, there's that. Anyhow, that's how I'm going to do it, but if you have an angle meter, use it. I mean, don't even don't even question it. So I'm going to start with this breaker bar here, and I might try this cheater pipe as well on the end of this. I don't know if it'll fit. If it doesn't fit, then I'll have to use this pipe, and if I'm using this pipe, I'm using this big breaker bar because, well, it's a lot easier and it's a lot stronger anyway. Heavy, though. Another comment I want to make about these angle torque specs. Whenever you're using an angle meter, always make these marks. Don't rely on that angle meter to be accurate. It can be the nicest Matco or Snap-on angle meter. Make these marks to make sure that you went all the way, because I will reference Adept Ape's video again. Even as a nice Snap-on angle meter was still maybe 15 or 20 degrees off at its worst. So the way that I do this is I torque, 30 degrees, pull off the socket, and then put it back on. After I checked, do another 20, pull it off, and then torque it to where I think it's going to end. And as you can see, they all got to where I needed them to be. And then again, make sure that your crank isn't binding after every torque sequence. That'll save you in the end. If you make a mistake and one of them gets cockeyed and makes your crank bind, then you'll know after this set of steps that I just took, i.e. torquing, then I need to take it back apart and make sure everything's right. So the next thing I'm going to do is torque all these to 18 pounds per the instructions here. Those are 12 mil 6-point head. So the torque goes 1, 2, 3, 4 on this side, back to front, and then 5, 6, 7, 8 front to back on this side. And then again, make sure, it seems to rotate freely. No up and down movement in the back end. No excessive front back movement. Ugh. So, great. The other thing that you'll want to note is that torque wrenches are generally most effective in their middle 40 to 50% of their range. So 75 over 2 is 35 pounds. And then 35 over 2, 15, 17 and a half. So 35 plus 17, 45 plus 7, 53. And then 35 minus 17, 16, 18. So between 18 and 53 pounds, roughly, would be where you'd expect this torque wrench to be the most accurate. That's just a rule of thumb that they use. The other thing to note is never store your torque wrench with any torque applied to it. So what I like to do is back it all the way off, past the 0 mark, and then tighten it just until you start to feel resistance on this handle. Or just to 0 on this shitty Kmart big wrench. That way it doesn't, store torque in it and warp the leaf springs in there that actually read out how much torque you're applying or how much force. Now I know there's a lot of videos online of people wrenching on their dope-ass Yodas that make it look like a glorious process or like they're building something, but poverty will do things to a fella. I am using this shop by the grace of my parents' neighbor, Mr. K. God bless him. He is so kind for letting me use his shop. But notwithstanding, cleaning. 50 to 75% of the time that I spend working is spent cleaning. Right? You look at the amount of old carbon sludge and other bullshit that accumulates in an engine over 100,000 or 150,000 miles, especially gasoline engines. They're just gross. And you start to realize why it takes so long to get anything done. But luckily, it looks like the kerosene did a pretty good job of loosening up all this carbon. So what I'm going to do is I'm going to do these rods one at a time. I'm going to take them out one at a time from the kerosene bucket, drain them as you just saw, and then I'm going to take the bearing shells out of the crankshaft, or of the big end of the connecting rod here, rather, as well as the bolts, and then I'm going to clean them. But again, like I said, I'm going to do this one at a time because I haven't marked these with a punch, because of course I don't have a punch set that's numbered, and I don't really want to fixture each one of these in the bench vise and then drive dots into them. Maybe I will do that. I don't know. Either way. Now, if this were a cracked rod, or a scored rod, as it's known, then this would have been cast as one piece at the factory, and instead of being machined flat right here, the manufacturer would use a die or something to score a line, maybe 50 thousandths of an inch deep, around the rod, and then they place a chisel there and they smack it. Or, I don't know if it's a chisel or a punch or what. And then the crystalline structure of the forged steel or cast iron or whatever happens to be the material of your rod cracks. And that cracked material means that it fits together perfectly like a puzzle piece when you put it together. But that also means that you absolutely have to keep them not only with their respective connecting rod, but also that the cap has to be in the correct orientation. You can't flip it 180. So just keep that in mind. Neither that IDI nor this, I don't think, have cracked rod caps, but I know a lot of Chevrolet products do. It's honestly the better way to do it. But, you know, to each manufacturer their own. Anyhow, I'm going to go through and clean these with brake clean and a nylon brush because I don't want to score these aluminum piston skirts. As you can see, they're already pretty worn out, but the engine had good compression and didn't seem to consume oil, and it's Toyota parts, so I'm just going to run it because I don't particularly care to spend another $2,000 to $3,000 on internal engine components. Like main bearings would probably be $200 to $300 for the set. Rod bearings would probably be likewise a couple hundred per set, or for the set. And then if I had to buy any connecting rod or main rod bolts, you know, there's another $50 for each of those sets. And then pistons would probably be $600 to $800 as well. And I didn't have the cylinders bored out, and that's probably $300 right there, bored and then honed, $300 to $500. And then, you know, checked for taper and all the other checks that they do. It's just expensive. So if you're trying to do this on a budget and can get away with it, then great. But the other thing that I want to note is you can probably see there's a little bit of schmoo down in the bores of these cylinders. So I'm gonna have to flip this fucker over and clean it out with a shop rag and some brake parts cleaner, but I'm gonna have to be really careful that I don't knock it down into the crank. And then when I'm done, I'm gonna spray everything down in here with brake clean and then blow it out with that air chuck because I was stupid and didn't do that. And in fact, I might clean them out with the engine upside down to use gravity to my advantage. Oh, and then you can note here, those are the drill marks from where the factory puts the crankshaft in a vise with bob weights attached to each of these crank journals. And then they spin it up to speed and they see how much mass to drill out of each of these counterweights on the connecting rods, or on the main webs here. So that's the main web, and there's the fillet, this part, and then here's the cheek is above the fillet. I'll actually grab a pick here and show you. So this is the oil hole right here. This is the main journal surface. This is the crank fillet, or the fillet, depends on how you want to say it. And this is the cheek. And then this is the main web that connects these two together. This is the counterweight, and here's another counterweight. And then on the back side of these are both thrust surfaces that go against this main cap. As you can see, this main cap, if I measure it like that, it's a little bit thicker than the other ones to ensure that the thrust washer has something to, you know, butt up against. It's not gonna warp. So I was doing some reading while I was on the shitter 2 days ago between classes, and I just had this hankering to look up the old 8.2 fuel sipper Detroits, and I forgot what a piece of shit they are, but they're a medium duty or industrial diesel, and they have short skirt pistons, and they have open block decks, and they only have 4 bolts per cylinder. Now in a non-turbocharged sub 13:1 compression ratio automotive engine, that's just fine. These engines will last 300,000 to 400,000 miles if you do your coolant maintenance and don't overheat them. But in an 8.2 diesel, especially where they were running boost in, you know, a Chevy C60 or a Ford L7000 or you know, whatever, really, they blew head gaskets all the time. And apparently of the 300,000 8.2 Detroits that General Motors Corporation built, 100,000 of them were fucking spares because they blew up so often that a third of their production had to be dedicated to producing spares for warranty. And that's, yeah, kind of a testament to why I don't like open deck blocks. It's because they don't hold up to the demands, especially of an industrial engine, quite like a closed deck block does. Like that IDI over there. More area for that head gasket to grab onto, as well as less walking back and forth of the cylinder liners. Now, another thing that I thought was kind of interesting was whenever independent companies were doing failure analyses, they would look at these cylinder liners, and I think they were Siamese like this Toyota's is, but the liners would cant, or they would twist to one side or the other. And oftentimes at the base of the liner, oh, that was my arm. At the base of the liner, though, where it attaches to the block, there'd be a massive crack where the liner had failed. So if you're going to buy something with an 8.2 Detroit in it, I'd recommend not, or I'd recommend sourcing like a Cat 3208 or a DT466 non-electronic, a P-pump DT466, or hell, even an old IDI diesel, you know, out of an old Ford or something else with closed decks, and preferably with removable wet liners if it's an industrial engine so you can in-frame it. But word of warning from the wise anyways. Okay, so America. All this shmoo came off of the top of the pistons. As you can see, it's flaking pretty well right there. So I've got a nylon brush that we're going to go ahead and clean the sides of these with. And I might get a brass bristle brush for the top, depending on how caked on this shit is. But for the sides of the piston, for the skirts and the ring lands and grooves, I'm going to just use this brass bristle brush. I emptied the kerosene all the way out to get most of this shmoo out. And speaking of which, I should probably... Oh, got a little of the good stuff. That's just blacker than sin. Anyhow, I'll put that on the floor. I'm going to go ahead and just soak this. This is rod number 1, and I'm going to keep the mark forward. So actually that way's forward, and let's go see if it's the same way on all the pistons, because if it is, then I won't need to keep the marks. I'll just do it one at a time. 5 is forward like that. 3 is forward like that. 4 is forward like that. 2 like that. And then, okay, so the notch means that they go forward. Great. And I'm not taking the wrist pins out. These are full float wrist pins. You can tell because there's circlips on either side. And because the wrist pin can move, well, you can't see it, but it moves inside of the piston there. So, again, another thing, and I'll show you this when I get that far, but these connecting rod bolts are neck down. Now that right there is a traditional torque to yield bolt, and so what you want to do is measure at anywhere along the shank the diameter using vernier calipers and see how wide it is and if it's below the factory spec. Oh, let me pull up that factory spec real quick here. Connecting rod. Shit. Where is it? Where's the compression? I thought it was in here. Oh, there it is. Connecting rod, neck down, minimum 276 thousandths right here. And then standard is 283 to 287. So get your caliper out. If it's under that 276 mark or whatever it was, then replace your bolts. If not, you're good to reuse them. All right, so the oil ring, as you can tell, is a little bit fouled up. It's, you know, used piston rings, but this is about as clean as I think I'm going to get this piston. I don't really see the point in going any farther, but I did get the area above the ring lands clean. I'm not going to do below the oil control ring because what's left of the whatever, I think this is a Teflon coating or something similar, non-stick coating, I'd like to not disturb. I might go ahead and do a little bit more scraping. I was using this pick, so what I did is I fixtured the piston and connecting rod in the vise, like so, and then I used the edge of the pick to, let me show you, just scrape along here, like that. And I'm not applying very much pressure because I really don't want to. I don't really care about the face of the piston itself, but the rings I really don't want to bung up. So, you know, I'd push this ring down, as you can see, like that, and then the other ring is still up, and then I'd go over it and get in between them. It's easier when it's not resting on the rings to show you, but I'll show you in the next one. That's about how clean I think I'm going to get it, though. Alright, so here's the ring compressor. I'll show you how to use that in a bit. First things first, connecting rod bolts, 283 thousandths roughly on both of these guys. So that's good. Now this piston ring compressor is a sharp piece of shit. This one is it's a Lyle piece, but what I need to do is is get like a band or a fucking the BDSM wrench or something to hold on to it with so I can drop these pistons in. I made the mistake of doing an oil change 50 miles before I pulled the motor, so this oil is almost brand new. So what I'm using it for is lubricant for the pistons. So as you can see, I already got one piston in. These bolts have been cleaned, and now I'm going to let them soak in oil and the excess drain off. But what I do is, this is piston number 1. So I put some oil on the inside of the cylinders, and then I'm just going to use my hand to smear it around. Just a little bit. You don't need a whole metric fuck pile of it, but just like that. Back of my hand all over. I can wipe that off on a towel. It's new motor oil, so I'm not worried about it. And then you'll notice here the piston's all the way down, and it's against it, or it's almost all the way down. It's against its journal right here. I do that so that way I can control it once it gets down, so that way when I tap the piston in out of the piston ring compressor, I don't smash the end of the connecting rod into the freshly polished journal here. That way I can, again, like I said, guide it in. These tangs go toward the front, or the 2 little dowel pins on the bottom of the connecting rod there. And then piston slides in like so. Somebody already nicked this. They're machining it, which is unfortunate. Either that or I did, but I don't think I did. So I had this thing under wraps in plastic until I got it here. So anyhow, I'll show you how to compress the rings once I get another piston clean, and then I'll show you how to put it in. Using a hammer and this fine-tipped punch, I am going through and marking 3 dots on the connecting rod and the rod cap. Next thing that I'm going to do is, you can see this one's flaking off pretty well. My throat's all scratchy and dry. Anyhow, I'm going to go through and use the pick, just like so. And then I'm going to gently pick all the carbon off all the way around. As you can see, it's a pretty tedious process. I'm being very gentle so I don't score the shit out of the piston rings. Fuck, you can't see that if I'm on the floor. And as you can see, this takes quite a bit of time. So it's quicker than using a nylon brush. I don't want to use a brass bristle brush because brass is harder than aluminum, and I have no idea what these piston rings are made out of. So in the off chance that the brass is harder than the piston rings, which is extremely doubtful, I don't anticipate any manufacturer today would be that stupid. But I'm going to just do it very carefully with this pick, especially since I'm not putting these through a parts washer. And then I'll go through and use my brass bristle brush on the top and on the connecting rod here. And I got to pull these bearing shells out as well. Word of warning, not only is this fixtured in the vise, but there's a 3rd point of contact right down here where this is rested against the bench vise. Then I had this just finger tight snugged, but snugged enough that it wasn't gonna warp the dowel pins or anything when I punched in which number this rod assembly was. I haven't put the first main cap on yet, or the rod cap rather. So it is tightened to, I think, 22 pounds and then an additional 90 degrees. So as I do this, I'm going to put each rod cap on. And when I finger snug them up, I might even use a ratchet to, just give them a little tightness. I'm also going to put some of that lubricant on them. And then I'm going to flip the motor over once all the pistons are in and do the torque spec so I don't have to do it from underneath, because that sounds miserable. Okay, so I've soaked the piston in this oil here and I let it drip off, and now it's only got a little bit that it's dripping. Fixtured it in the bench vise and I loosened off this ring compressor. If you get the Lyle version, be careful that you don't cut yourself because they're pieces of shit. But before you put that on, you want to go through and then look at where the edges of the compression rings are. I can't move the oil control ring, so it's kind of stuck where it's at. It seemed to be fine before. Set the ring 180 degrees apart. So this one's over here between the main thrust area of the skirt and the wrist pin. lower control rings over here, meaning the upper control ring will be, or the upper compression ring will be 180 degrees off right here. And then I also made sure to put some oil on this wrist pin here. I forgot to do that on the other one, but I let it soak in the oil bath long enough that the piston filled up, so it should have some oil in it anyways. Now, once you've gotten your rings lined up, let's see if I can, yeah, let's go ahead and scrunch your ring compressor like that. Place it over the top. And make sure you leave the bottom little bit of the piston skirt exposed. And then tighten, just like that. Alright, so now I've got the piston and connecting rod assembly in. And as you can see, I've got the rod dropped into the hole. Oh, this thing really won't focus worth a fuck. Okay. And then right there, so here's the connecting rod. And down in there, yeah, you can just see the fillet there in front of the tip of my middle finger. So that's what I'm going for. I rotated the engine over so that fillet was again all the way at the bottom. And you can see I've left the bottom of that piston skirt exposed so I can put it into a pre-lubricated cylinder. And then I made sure too that the dowel pins are on the front side of the connecting rod. The B is also toward the front, just as it is over here. Right there's the B. This one's better exposed. But, well, if you don't catch your rag, you can then, again, go underneath, take a look, make sure. Okay, yeah, that dowel pin up in there is toward the front. And then, to make sure it's totally lined up, you can go ahead and rotate it, looking underneath, rotate the top. And then we're going to go ahead and use a soft mallet, and I use the bottom of it, and I'm just gently and there it goes. But you'll notice I never got more than an inch away from the top of the piston, and I wasn't doing it super hard, gentle taps. That way I can allow the connecting rod to move back and forth on the wrist pin too if it hits the crankshaft counterweight. And then I like to wipe the oil off the top of the piston once I'm done, just because I don't really want to foul the spark plugs up when I first start the engine. Granted, there's enough oil on the cylinders that it'll probably do that, but just, you know, puddled oil isn't great. Anyhow, I'm going to push this piston down while I watch underneath to make sure that the big end of the connecting rod slides over the fillet there, or the journal rather. Oh, and I forgot, but I should probably lubricate the bearing and put it into the connecting rod there as well. Bearing's still over there on the bench, but I'll do that here in a minute. That's nothing you ain't seen before though, so yeah, I'd recommend putting that bearing in first, because now it's going to be a little bit more difficult. But yeah, the main key is just go slow with these, have patience. Also, you'll notice I wasn't going super hard on it, wasn't rocking it back and forth so I don't damage the freshly machined mating surface here on the engine block. All right, 19 fucking hours later, and we're finally ready to torque these down. God, those pistons took forever to clean. Anyhow, so I'm going to do the back two and the middle two, and then we'll rotate the motor over to the top two. I have to use the ratchet to turn it over, which is exactly what I expect, because there's a fair bit of friction between the piston rings and the cylinder walls, but everything seems to turn smoothly and it doesn't bind up. That's really what I'm looking for, just consistency and no binding. Binder, stop binding. Anyhow, so the torque spec is 18, followed by another 90 degrees. So I got the trusty paint marker. Doesn't matter the order that you do these in, because, you know, they're each separate or floating caps. So anyhow, yeah, another thing that you want to make sure is that whenever you drop these down and drop the pistons down their bores, that you don't break one of the oil squirters. That would be a bad time.